Hello, in this video I'm going to look at working with integrals. So whenever we work with integrals, we look at the topic of even and odd functions. Now, whenever we talk about an even function, basically we mean, for example, if you have y equals f of x, if you substitute negative x into f, so if I have negative x equals to f of x. Basically, this tells me that I have that this function is what we call even. Now, one way to display like what do we mean by even is, for example, we can say that a function that has symmetry with respect to the x-axis, such as like the parabola, like if we have something like this, then this is an even function because we have that it's symmetrical to the x-axis, well, y-axis, sorry. But if we have, for example, that we take a function y equals f of x and we have f of negative x and then we get minus f of x, well, this says that the function actually is odd. Now, when we can think about this, like whenever we have an odd function, basically we have that the function is a bit symmetrical to the origin. So we have that, for example, if I was to, let's say, if we were to graph a function that looks something like this, then in this case we would say that this function is odd. Well, and this is the function y equals x divided by x squared plus 1. Okay, now the thing that we can do with even and odd functions is look at certain properties. So, for instance, if we know that a function is even and we have that we're integrating from negative a to a of f of x dx, well, essentially that means that you have 2 times the integral from 0 to a of f of x dx. Now, of course, we know that the antiderivative of f of x would just be whatever we can find it to be. But yeah, any way that we might look at it is that most definitely you have that the region of which that the area happens to be, um, it's going to be symmetrical. So like for example, if I had something like this, then I know that from negative a to a, that the region that lies beneath the curve, it's going to be symmetrical any way that you look at it. So we know that we can just look at just one piece or one part of it from 0 to a or negative a to 0 respectively. But you have that with an odd function is such that you have that you're still integrating from negative a to a, except in this case, when we integrate that function f of x dx, it's actually going to give you 0. Now, one way to think about this is that, well, you have that one way to look at this is that we are calculating net area. So if we have, for example, like regions of which that are below the x-axis and above the x-axis, they actually might cancel themselves out. So let's say, like for example, like if you were integrating um, like x cubed, and you were integrating from like negative 1 to 1, then in this case you're going to have that if you integrate from negative 1 to 1 of x cubed dx, well, this is just going to be x to the fourth divided by 4 from negative 1 to 1. but that's 1 minus 1 divided by 4, which is equal to 0. So it's like the two areas, well, it's like the two areas, they cancel themselves out, because in this case there is no gain. Uh, there is no net area that's gained. So you have that those two areas actually will cancel themselves out. So how we can use this to our advantage is mostly just by recognizing that a function is even or odd. So for example, like I know that if I integrate from negative pi, pi over 2 to pi over 2, and let's say like this is sine of x dx, well, I know that, for example, that this is going to have to equal to 0. And one way that we can do that is that we know that, well, sine of negative x is equal to negative sine of x. So I know that the function is odd. So in that case, I know that when I integrate this, this is going to be equal to 0. But then if I look at from negative pi over 2 to pi over 2 of cosine of x, well, this is going to be equal to 2 times the integral from 0 to pi over 2, and that's going to be cosine of x dx, but this is going to be equal to 2 sine x from 0 to pi over 2, which basically means that the area is going to be 2 units squared. Okay, and of course, like, we can look at both of the regions as needed. So like, for example, like with cosine we have that basically the area that lies beneath the curve for cosine. Um, let's see. It looks something like this, of which, it's not really to scale, but, we try our best. So we have that this is going to be our region, of which apparently is 2 units squared. Okay. Now, we can actually look at an example though. So let's say that we want to find the integral from negative 2 to 2 of 16 minus 3x squared dx. Now, one thing that I'll note is that for sure this is an even function, mostly because of the fact that if you have that this is f of x equals to 16 minus 3x squared, if I do uh, f of negative x, well, even though we substitute a negative, we still get the same thing. So this function is even. Now, what I would do next is I would just say, well, this is definitely equal to 2 times the integral from 0 to 2 of 16 minus 3x squared dx. Now, what comes next is that basically we have that this is going to be 16x, and mind you, that's times 2, from 0 to 2, and then we have minus 3x cubed divided by 3 from 0 to 2. So we have that this is going to be 2 times 32 minus basically 8. So this is going to be 2 times 24, which is equal to 48 units squared. Okay, so yeah, all that we needed to do here was just take the antiderivative of this and then just double it, if anything, from 0 to 2. Now, similarly, if we were to, let's say, for example, look at where we want to basically find the integral from negative 1 to 1 of x divided by x squared plus 1 dx. Now, this is definitely an odd function due to the fact that if you have f of x equals to x divided by x squared plus 1, no matter what, if you put the negative x into there, you're going to get negative x divided by negative x squared plus 1, which is still just equal to minus x over x squared plus 1, which is negative f of x. So I get that this function definitely is odd. Now, what this means is that basically that this area has to be equal to 0. Okay, now in the event that we didn't know like how to do this, well, you would have to show that this is going to be 1/2 the natural log of x squared plus 1 from negative 1 to 1, which would actually just be 1/2 multiplied by ln of 2 minus ln of 2, but that just gives you 0. Now, keep in mind that if we wanted the total area, then in this case it would be totally different. We would have multiplied by 2, meaning that the answer would have been natural log of 2, but that's not what it says. So yeah, this is just going to be 0. Now, another thing of which that we do look at in this section is average value. So whenever we look at the average value, um, basically we find the average value by saying that we have that if we integrate from a to b of f of x dx, if we multiply this by 1 over b minus a, this is going to equal to what we call the average value. Okay, now keep in mind that basically what this is saying is that we have that if we were to integrate from a to b, that we could probably just add up all of the areas and then just take the average basically. But essentially it just gives you this one formula. Now, one way that we can view this is, for example, where we have, what if we said that the average value was equal to f of c? So let's say that this was the average value. Well, what that would mean is that essentially you have that f of c is equal to 1 over b minus a, but multiplied by the integral from a to b of f of x dx. Now, this actually gives us a nice little result that says that we have f of c multiplied by b minus a is equal to the integral from a to b of f of x dx. So essentially this is like saying that if we were to look at, let's say like we were to look at a region. Okay, so like if we had a region from A to B, and let's say that, for example, that we were just going to integrate this from here to here. Okay, so we have that that's going to be our region beneath the curve. Okay, so let's say that, okay, this is, the area that's beneath the curve, and of course this is a trapezoid, meaning that we can find this area very easily. However, what the average value is saying is that there's a constant c such that basically when we find this constant, it takes on the average height, or it takes on the height, and then what it's going to do is it's just going to find that the total area matches. Okay, so that's actually kind of interesting that we have that the total area matches uh, when we find the area by doing b minus a, because that's the distance of the base, times the height, which apparently will equal the same thing as the integral. Okay, well, let's actually see like how that works. So let's say that, for example, that I have, okay, so let's say that we want to find the average value of f of x equals to x squared plus 1 from negative 1 to 1. Okay, so accordingly, this means that we would have to do that we have 1 divided by 1 minus minus 1, and then multiplied by the integral from negative 1 to 1, and this is going to be x squared plus 1 dx. Now notice that this is going to give us 1 half multiplied by the integral from negative 1 to 1 of x squared plus 1. Now, interestingly enough, we have that this is actually an even function, which means that we can double it, which basically means that the 1 is going to cancel out, or the 2, sorry. So you have like 1 half multiplied by 2 multiplied by the integral from 0 to 1 of x squared plus 1 dx, and this is equal to just the integral from 0 to 1 x squared plus 1 dx. And we're going to do this one more time. We're going to have 1/3 x cubed from 0 to 1 plus x from 0 to 1. Now, what this is basically telling you is that the average value happens to be 4/3. So we have that this is going to be equal to 1/3 plus 1, which is actually just going to be 4/3. Now, this isn't really telling you what the integral is equal to. It's telling you that the average value is equal to 4/3. So if that's the case, then that means that basically that there is a function value that will equal to 4/3. So if that's the case, then you can actually figure out from negative 1 to 1 where would that happen at. So apparently the value that allows you that, so you would have to say like c squared plus 1 equals to 4/3, and then from there you would just end up getting c squared equals to um, yeah, so this is going to be equal to 1/3. Okay, so that means that c is equal to plus or minus root 3 over 3. So from here, this is where you would have to figure out like where this would lie. So we can see that basically like if we were to do the computation for this, it would tell us that the value that gives you approximately uh, the average value is 0.577. Now keep in mind that if you multiply this by, when you plug this into the function value and you multiply this by b minus a, that's going to give you the integral, which in this case the integral is 8/3. Now, so we can actually look at another example where we have, let's say that we go ahead and we set up the function. So we have, let's say that we have f of x equals to 1 over the square root of x, and we want to look at this from I believe it's going to be 4 to 9, and so we want to find the average value, and we want to find the point. Okay, so what this means is that all that we need to do here is just say that, okay, so we know that we have some function of c is equal to 1 over 9 minus 4, the integral from 4 to 9 of 1 divided by root x dx, and this is equal to 1/5. Okay, so in that case, this is going to be, okay, so that's going to be the integral of x to the negative 1/2 dx, which is equal to 1/5 uh, x to the 1/2 divided by 1/2. So this is going to give me, oh, and yeah, it's from 4 to 9. So this is going to give me 2/5, and then I have the square root from 4 to 9. Okay, so from here, basically all that we have left is that we just need to say, well, we have 2/5, and then we have root 9 is 3, minus root 4 is 2. So that's going to give us just 2/5. So the average value is actually just 2/5. So from there, what we just need to do here is just figure out, like, yeah, what is the function value that gives us 2/5. So we'll go ahead and say that, well, we have 1 divided by the square root of c is equal to 2 over 5. Now, basically, what we could probably just do is just say that we have the square root of c is equal to 5 over 2. So that means that c is equal to 25 over 4. So basically, we have that the constant c that gives us the average value is 25/4. Now, of course, we do need to check to see that 25/4 is within the interval. So 25/4 divided by 4 is equal to 6.25, which definitely is contained in the interval from 4 to 9. So this does work out. Okay. Now, just be sure that you are able to kind of use either or in terms of like using mean value theorem. Of course, it is required that the function would have to be continuous uh, on its domain. So, like, you know, we know that the antiderivative will exist and that we can evaluate it, but most definitely if it's, as long as it's integrable, then essentially we have that it should work out. So yeah, the only formulas that you really have from this chapter is really just the function value is equal to 1 over b minus a, and then you have the integral from a to b of f of x dx. And then of course like the others about the even and odd, but basically you kind of have the idea that if it's even, then you have that it's 2 times the integral from 0 to a. And then if it's odd, you know that if it's odd function, that it's basically just equal to 0. So just recall that this is only for even and that this is only for odd.